Hi. Hi, everyone. Hi. Please write a plus in the chat if you can hear me. Is the sound okay? Tell me. I need some feedback. We already have so many people watching us. And I would like to know, is there everything okay with the sound? Sound is okay. Okay, you can hear me. You can hear me. That's great. Okay, great. I think then we will begin. Welcome, everyone, to the final stage of the Scratch Olympiad. My name is Jules. I will be your host today. Well, I'm not Jimmy Fallon, but well, I'll try my best to keep you entertained. What will be happening here today? So, if you have seen the program of the Olympiad, you probably already know that today there will be 3 workshops from amazing teachers from Robbo. They will be very interesting, I promise you. The workshops will be about programming on Scratch, 3D modeling, and circuit engineering. I hope you will stick to see them all. All 3 of them are really amazing. Also, what will happen? I will tell you where to find the tasks in Olympiad. I will tell you what to do with those tasks, all the deadlines, all the rules. I will basically explain that to you. Okay, what else will happen? We not only have participants here, we also have many guests of the Olympiad, like so many guests registered just to watch this and to be a part of that amazing event. So today I will also announce some quiz for our guests to keep them entertained. Hopefully, when you pass this, I will not tell you what it is yet. Okay, that will be a bit later. All right. Okay, but yeah, not only participants and finalists will get prizes in our Olympiad, but also guests will be uh, kind of a uh, they also will participate and they will also get a prize. Let's just say that. Okay, so let's talk a little bit about our supporters. Who supported Scratch Olympiad? Who was our sponsors? The sponsors of the Scratch Olympiad are of course, the manufacturer of educational robotics, Robbo, which has offices all over the world. You can find them and you can even maybe study there if you're interested. Robotics, I mean. Okay, also we are supported by the extracurricular education movement, the Agency for Strategic Initiatives, the University 2035, the Skolkovo Foundation, the Aalto University in Finland, and many other organizations. We thank you all for making this happen. Also, we want to thank our participants and guests that donated to the Olympiad. That also helped a lot. We were able to do so many great things because of your donations. If you want to donate today, you can find the donation link on the official website of our Olympiad. Okay, so what is happening? Today is the final stage. The winners of the selection stage of the Scratch Olympiad will participate in this competition to win the crown, let's just say. Today we will have 210 participants in the final stage from different countries all over the world in 5 age groups. We have people who are really just a kid yet. Then we have people who are over 18. So it's all ranges. I propose that you write in the chat your age. And I would just like to see how many people of a particular age are watching this translation right now. That would be great to know. Also, if you don't mind, that would be interesting to know the country you're from. So please state that too. Write your country in the comments to this broadcast. Okay, so I welcome you all here, and I would like to announce that we begin the acceptance of final tasks for the Olympiad. What does it mean? You can go to the official website. You remember that, right? creativeprogramming.org. And there you can find the final stage task link. You need to press that link, and there you will see your nominations. You need to choose your nomination because each nomination has different tasks with different complexity. So basically, if you choose a Kate nomination, that would be a bit easier than a team nomination, obviously. Yeah. So you choose your nomination, and there you will see 3 tasks for your nomination, right? Right. What are those tasks? The first task of your Olympiad tasks will be a quiz. What does it mean, a quiz? Well, those are just simple questions about Scratch, just to, find out how well do you know the Scratch programming language. Okay? Great. Okay, then there is a second task. That's an algorithmic task. There will be a task with an algorithmic problem that you will need to solve. Okay, that should be pretty enough for you because I'm pretty sure you are all geniuses here. And there is a third task, of course, which is called the creative task. The creative task is something special that we came up with. That is a task that solves some world problem, some global problem. You will have several tasks to choose from. You need to choose just one, and propose your solution to the global problem. Now, what will happen after that? After you propose your solution to the global problem, we will get your tasks, we will check them, and the best answers to global problems will be sent to UN with an open letter. We will say like, hey, here are our best participants, their best projects, and we hope that their solutions will help improve the world. So basically, you are not only participating in the Scratch Olympiad, you are making the world a better place today. Okay, once you're done with all 3 tasks, there is a link that says submit tasks. You need to submit all these 3 tasks by pressing this link. Please don't forget to give us access to your works, or else we won't be able to see them and we won't be able to check them consistently. So you got it, right? You go to the website of the Olympiad, press final stage task. There were 3 tasks. To complete all 3 of them, you have until tomorrow, until September 20, 23:59 UTC. I hope you will have enough time to complete all 3 of them. And before that time, you need to press the submit link and submit all 3 of them. Okay, then our great guests. I welcome you all here too. And we have a little surprise for you. If you go to creativeprogramming.org, you will see a link that says Scratch quiz for the registered guests only. It will be available on September 19, 2020. So that Scratch quiz is especially for you. Well, what is it? It is a huge, well, not that huge, but it's a big test on Scratch where you can test your knowledge of the Scratch programming language, solve some tasks, and well, answer some questions. After you complete this quiz, you will get a special certificate that will say how good of a Scratch expert you are. It will be an official certificate of the final stage of the International Scratch Creative Programming Olympiad. Okay, so go to creativeprogramming.org if you're a guest, find the Scratch quiz link and try to complete it to know how good of a Scratch expert you are. I wish you luck. We accept the answers to quiz starting now. So you can already go and do it. Okay, great. Then let me see. Oh, you wrote that. Oh, we have many participants from Russia. 9 years old, 12 years old, 10. Okay, that's great. Thank you guys for writing how old you are. I appreciate it a lot. Okay, so in 5 minutes, we will begin our first workshop. Let me tell you a little bit about who will be telling you about this topic. So the first workshop will be about programming on Scratch. And your teacher today will be our great friend from Japan, from Robbo Japan, Keisuke. He is an amazing teacher and he will tell you everything in very interesting details, hopefully. Okay, so Keisuke, here's here's a word to you.
Hello, guys. Hi, my name is Keisuke. I can take off my mask actually. So this is Keisuke. Hello, I'm from Japan, and then I'm from Robbo, Japan as well. And then I'm so glad to meet you all, see you all. And so I'm the representative in Fukuoka in Japan. And as Robbo, what we do. So we do, we provide robotics educational lessons for children, consisting of 3 pillars. And one is programming, so learning how to communicate with robot. And 2, 3D modeling, learning how to build their own robots. And 3, circuit design, learning what the inside of the robot looks like and how the components make the robot move. And then I'm gonna take care of the programming and 3D modeling. But basically, as Julia just told you before, there are a lot of global issues, but you are the one who solve it. So we encourage all of you to be global leaders and innovators, and we all change the world together. Okay. So first, I'm taking care of the programming lesson. So let me change my mask again. Ho, ho, ho. All right. So let me begin with the slide. Go. I hope you can see it. Let me. Right. Hope everybody can see this. So again, we are Robbo, and then what we're gonna do is a programming. All right. So first of all, I hope everyone have heard what programming and programming. And as you can see, robot thought. But when you hear programming, some of them or some of you might picture the image like the left bottom corner, black screen, and there are a lot of alphabets and the sentences. Oh my God, so complicated. That's actually programming or how programming looks like. But what we're gonna do today about programming is on your right side. Sorry, right side. It's called Scratch, but we're gonna use our own Scratch called Robo Scratch, right? And you can see very colorful, a lot of colors, and then it's like a puzzle. So that you don't need to write so many things, but you can actually put together and put the block together, and then you can create your own things. And then actually, Scratch can do so many things, much more things that you can imagine, right? So let's think about programming first. What is programming? I know you have heard programming, but when you were asked what is programming or what's programming, so hard to answer it, right? So again, it looks like this. A program or programming is an instruction written in a special language, right? So as I told you, I'm from Japan, so my native language is Japanese. But as you can hear now, as you can see it now, I speak English because I learned it. So programming is also the same thing. It's a special language for robots or computers. So you can say this programming is a computer language as well. So when you learn this special language, you are able to communicate with robots and computers. That's why we need program or programming, because as you can see, a lot of robots or machines everywhere in our lives, right? And we want to communicate with them. We want to talk to them. We want them to do what you want them to do. So that's why we need to learn programming. All right. So questions. What is algorithm? Have you heard algorithm? Again, this is so difficult, and you don't need to explain the word actually, but some of you might have heard this word as well. So the easiest way is basically a cookbook for programming, for the game or everything. So algorithm is like this. You can see this description, but basically, when you cook something, and then especially for the first time, you're gonna open the cookbook. So you're gonna see the instructions, right? And you can do everything by yourself. I know, put the ingredients and how you cut it, and then what to do next, and then when you're gonna turn off the microwave or everything. When you look the cookbook, you can see everything. So algorithm is like this. You're gonna put everything that you want robot to do, and so robot will follow that. So it's an algorithm is a kind of cookbook for robot, and especially today. This one, Scratch review, and what you can see, it's like this. This is what you're gonna see today. Move 10 steps, and then this is a start button, and yeah, something like this, and a colorful. And today, what you're gonna see today is about linear algorithm. Especially, it's a type of algorithm, but it's called linear algorithm. What does it mean? So when you see the word linear, you might notice this word is similar to the word line. So the line is from dot to dot, and when you connect each other, it's a line, right? So linear algorithm is a line. So one line, it means from the top to the bottom. You just follow from the top to the bottom. So you're gonna just complete that program. When you see this, for example, on the top, you see start, and then go down, one down, and turn 60 degrees, and wait for 1 second, move 100 steps, and wait for 1 second, and turn 60 degrees, and end. So this is the algorithm, linear algorithm, and a robot will follow this order. So the robot is turned on and turn 60 degrees. So turn 60 degrees, and wait for 1 second, and then move 100 steps, and then wait for 1 second, and turn 60 degrees like this. So this is this is what robot will order. And today we're gonna use this linear algorithm, and I'm gonna create some like a cool program today. Today's program is called Bermuda Triangle. I don't know how many have heard a Bermuda Triangle. Hope some of you have heard. First of all, this is a mystery, you know. So the Bermuda is an area right next to the United States of America. As you can see, next to Miami and Tampa is all like the humid, so beautiful area. But there's an area on the ocean. In it's the area it's called Bermuda. There's a mystical triangle, and for many years ago, the airplanes or ships or cruised. Whenever they reach this area, suddenly out of contact, and everything disappeared. Everyone disappeared, and you cannot just reach out to them, and you cannot hear from them. And then for a while, and after a few days later, what was found is everything's about the scratch and the scattered ship and airplane. Every airplane was flying, but actually on the ocean, and the ship was sinking, everything. And then nobody just came back. So this is a mystical area that once you enter this triangle area, you cannot come back. So scary. Oh my God, this is a mystery. So today, I'm going to make this program. So hope you guys enjoy it. Let me share my screen with Robbo Scratch. All right. So everyone can see this. All right. So first of all, we need to change the character because today we are talking about Bermuda, not robot. So first of all, let's choose a character. We call it sprite. Okay. So when you choose a sprite, you can see here and choose a sprite. Okay. And then when you click it, you have so many options. Oh my God. I hope you're gonna enjoy it like this and bat there and bears here and the button, a cake. Oh, so yummy. And a catcher and a dinosaur, dragon, elephant, even griffin. Oh my God, so many things. Mermaid is here, panther, puppy, and rocket ship. Oh my God, and alphabet as well. Cool. But today we talk about Bermuda Triangle. It means everything's about ocean. So let's choose a boat today. You can search the character by typing like a boat, a sailboat, or you can just scroll down and you can find whatever you like. Okay. Here also sailboat. So let's choose a sailboat first. Okay. So first we need the boat, and then we got it. So the second thing what we need is a background, because this is just a white background and it's so boring, right? So let's choose a good background. We call it backdrop, right? The same thing when you click on the right bottom corner, you see you can choose any backdrop like you like. Something like a night city and a pathway, a play field, and when you go up, a baseball field. That's so cool, and a blue sky, and pool as well, and soccer field, and theater, everything. But today, let's choose like water things. So let's choose a city. All right, city water. Okay. And okay, what I want to do is let's draw some picture. So today, again, we talk about Bermuda Triangle. So it means we need triangle, all right? When you choose backdrop, and then next to code on the left top, there's a backdrop, and you have so many options. But when you choose line, and actually you can choose any colors you like. It doesn't matter which color is this, but let's choose yellow today, right? And point, and then you can draw like this. And again, you can draw like this. Ooh. And you can draw like this, all right? And this is completed. Cool. All right. And as you can see, the board looks a little bit bigger than we think. So click the board again, and then let's change the size. This is 100%. Let's make it half. All right, so 50. And you can put here like this, all right? Cool. And let's change the direction toward to a triangle. All right, cool. All right, so the basic rule is you remember the algorithm. First, what we need is start button on Scratch. This is the basic start button. When green flag click, blah, 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 this is what happened. And here on the right top corner, you see green flag. When you press this, it means start button, and then beneath of this will happen. All right. Okay, cool. So first, just in case, on left side looks, and let's set the size. All right, make sure the board is always 50%, a half, so it's not gonna make it bigger, it's not gonna be bigger. All right, so let's make sure that the size is always 50% of the original size of the board. All right, cool. And about the Scratch, you can learn so many theory as well. Today we're gonna talk about coordinate system, actually. So let's forget about the city water for now, and then let's see this one instead. This background is about coordinate system. Some might know coordinate system, and some may not. So let me just explain briefly about the coordinate system. So there's two lines. The horizontal, this is X, and the vertical, this is Y, all right? And then on the center of the crossing point is 0 and 0. It means X is 0 and Y is 0. So when you go right side from the 0.0, the X number of X will increase from 0 to this one, 240. On the other hand, if you go left, the number of the X will be minus, the negative, right? So from 0 to negative 240. The same thing happened on X, but instead of going right or left on Y, go up and down, right? So from the 0 point and then go up, so the number of Y will increase. On the other hand, go down, it means the number of Y will decrease. So you can tell where the board is according to the coordinate system. All right. So let me delete this background for a while. All right, and let's go back to the program. Okay, so the first, let's take a look on motion, and then this one, go to, let me make it bigger a little bit. I hope you can see this. Let me choose this one, go to X. Cool, go to X and Y. As you can see, when I move it, And this number will change automatically. So let me choose this first, all right? And then the program or computer, they work so fast. So you cannot imagine. So always make sure that wait 1 second, otherwise they are not gonna wait. And even 0.0000001 second or something, and then they're gonna just do their job and they're gonna get the job done. So always to make sure that at least like 1 second or something you can put it, all right? And then we want this board to go inside the triangle now. So we choose this again, go to, and then let's put -18 to -10. It means still on the left bottom side of the coordinate system, right? And then once they enter the coordinates, the triangle, we're gonna make sure that this ship will say something. In this case, because this is a terrified experience, we want them to say, "Oh my God." To short, we say OMG, but it means oh my God, all right? Oh my God. Keep saying oh my God for 2 seconds. And also, again, we want them to say Bermuda Triangle. Sounds scary. It looks scary, right? All right, this ship, it just enter the triangle and say, "Oh my God, Bermuda Triangle," and wait for a little bit. And then what is happening? What is happening is that this ship will disappear. Oh my God. All right. So there is a command called hide. So imagine this character, this sprite, both sprite move. And then when the algorithm reach the command hide, this character will disappear. It's so cool, right? So under this hide command, this character, the sprite, will move, but you cannot see it because it's hide. So the transparent character will move, and then you're gonna see it later. All right, cool. Okay, so again, let's make sure that it will, let's say, disappear. I mean, disappear, it means, let's say the border is sinking. So let's wait. Let's say for 2 seconds, all right? And what's gonna happen is that the board is sinking. It means it's basically upside down. So turn the degrees. How many? 180 degrees. It means almost upside down. Oh my God. Right? And then once it moves and it's sinking, right? So let's say 100 steps. So it's moving forward. Oh my God. It's sinking, it's sinking, sinking. And then finally we can find them. Imagine the height. So wait 2 seconds, turn 180 degrees, move 100 steps. Still, we cannot see it because it's under the command hide. So let's make it visible. And this command show. So now you use this so we can see this character. All right. And this is also the important command. It's called F on edge bounce. This is in a motion section. Here, motion section, all right? It means, as you can see on the screen on Scratch, on the right top corner, you see the visual, and this is a screen. So as you can see on the left side and the right side or up side and then the down side, you see the square, or actually rectangle, but each side it's possible that it disappeared. But if on edge bounce, it means when this character bump on the edge, they're gonna bounce it. So it means we can make sure that every time, no matter what happens, every time we can see the sprite inside the screen. All right, cool. All right, so let's see what's gonna happen. Enter the triangle. Oh my god, Bermuda Triangle. Disappear. And we can see it upside down. Unfortunate. Dun dun dun. But this is kind of strange for now. It's because everything's happened on the water. But we make sure, or we want the ship to be in the water or under the water, not on the water. So we choose another sprite. Sorry, backdrop. There's a cool backdrop called underwater. Okay, underwater. Okay. So let's program on the backdrop. Again, the start will be like this. When the green flag click, when you choose look, switch backdrop to the first one, city with water. All right. And then everything's happening, and then going inside the triangle, say, oh my God, Bermuda Triangle, and hide. So while that is happening on the ship, this backdrop can just wait. Let's say 7 seconds. And then the ship will be in the water, underwater. So let's make sure to switch the backdrop to underwater. All right. So let's see what's gonna happen. Go back to the character and then let's press this button. Oh my God! Bermuda Triangle disappeared and found on the underwater. Oh my God! Okay, unfortunate, but that just happened. All right. So, this is Bermuda Triangle, but this is not. This that happened only to one ship. Let's make sure that a lot of ship will come. So on the character, on the sprite, you click on right side, so you can see duplicate. So you can duplicate as many sprite as you want, and then all the program is the same, like this. It's kind of cool, right? All right. But we're gonna make sure that everything turned the same side, like this, right? And also like this. Oh, this is not. Okay. And also make sure that they head to the same thing, right? Like this. Okay, cool. And but let's make sure that here, as you can see, um, this first one is go to minus x minus 18 and the y minus 10. But if everything go to the same direction like this will happen. Oh my God, oh my God, oh my God. And everything will happen on the same thing. It's because I just simply duplicate. It means everything go to the same spot. So we have to make sure that everything will go to the different direction. All right. All right. So let's do it. So actually, right. Right. So let's make sure what's gonna happen. Oh my God! Bermuda Triangle. And then the four ships just stank. And let's try again. So whenever we try it, the same thing will happen. Oh my God! Bermuda Triangle. Dun dun. All right. So let's make it dramatic. We can also put sound on it. Go to sound on left side and then make sure that only one character, let's say the first sailboat, and then choose start sound. The first one is pop. It's on the hide one. So once they hide it, you can hear the sound. And then you can choose the sound. Pop is not so interesting. So let's choose cool one. Mind music, kind of cool things. And let's choose a good one. It's called the perfect one. We found it. Cool. All right. So hope everyone can hear the sound. Let's see what's gonna happen. Oh my God! Bermuda Triangle. Oops, sorry. My mistake. My bad. Sorry. I just choose the sound, but I forgot to select the cool sound. So now, dun dun dun. I just chose the sound. So let's play again. Oh my God! Bermuda Triangle. Oh my God! And then they are found on the water. Oh my God! All right, cool. I mean, what happened was not so cool, but this is a program of the Bermuda Triangle. And then let's see what we learned through this program. Let me share the screen again. All right, so this is what we learned. So this is about Bermuda Triangle, but to do this, we use linear algorithm. It's like from the top to the bottom, from the start to the end. It's like a straight. And the sprite looks command, and we use costume. So we draw the triangle on the backdrop, and then we use background. It's called backdrop. And then show and hide command, we used it, and the character size, we change it from 500% to 50%. And that's what we do. And also we did the duplication. So we duplicated the boat, and we created 4 boats uh, in the end, right? So this is what we learned. So to do the program, and you can learn so many things, and then caution, and so many blocks, and then so many theories. We also learn coordinate system, and then degrees as well. So actually, you can learn so many things through this scratch, right? Okay. So yeah, on the program part, my part is done. And as you can see, the time flies so fast. But I hope everyone enjoyed this program. And then I really hope to see you soon. And I see you next time. All right. Thank you very much.
Thank you so much for such an amazing, and I mean amazing workshop, Case Kit. I hope all of you guys tried to do the same thing as Case Kit did. It was super fun. He's a real Viking, as you may have noticed. That was really, really interesting, I think. Okay, so please write in the um, chat, what have you done? Was it successful? Did you manage to do the triangle and the boats and the sound? Please share your experiences in the chat. Also, you may find a QR code on the top right angle of your screen, that is a special QR code with a free trial lesson on programming in Robbo schools, in Robbo clubs. So if you just use this QR code, it will lead you to any free programming lesson that you may find or may want to try. Please, please try to sign up for these lessons because they are very interesting and I hope they will be very useful to you. Okay, so QR code, free trial lesson. Got that. Okay, what else? I remind you that you have three tasks, and to complete all three of them, you have 36 hours. 36 hours. Okay, you will also see the deadline where the tasks are. Okay, you have 36 hours for three tasks. The tasks are on creativeprogramming.org. You may find them in the link final task. I also hope that the guests of the Olympiad have already found the Scratch quiz. You don't need to register as a guest to participate in the Scratch quiz. If you just want to test your knowledge of Scratch for free, of course, and get a certificate of how good of a Scratch master you are, please go and find Scratch quiz link on creativeprogramming.org. If you liked the workshop, if you like the Olympiad overall, all of its stages, if you appreciate the work of the organizing committee, please donate to Scratch Olympiad. Anything you can, any number matters to us. You can also find the link on official website of the Olympiad, and there will be a button donate. Okay, very great. We have two more workshops left. Another workshop by Keisuke about 3D modeling, and then you have a workshop about circuit engineering. So, Keisuke, come back to us.
All right. Oh my God, I'm under attack. Woohoo! Actually, I just I'm under attack. Oh my God! But I need to do this one. So, hope you're gonna enjoy it. And then I'm not gonna rush, but let's begin. All right. So the next topic will be a 3D modeling. Woohoo! All right. So we did programming and next 3D modeling. What is useful for 3D modeling, especially for robotics, is that you are going to be able to build the body of robot. For example, have you seen Baymax? So on the Baymax, so Baymax is the cute robot and a nursing robot, and it looks white. But on the movie, there's a scene that the hero, the character, built the armor for Baymax. And then on that part, you're gonna see that he's using 3D modeling. So like this, so you can create the body of robot with 3D modeling, and this is very useful. But to do the 3D modeling, let's see what you need to know to use 3D modeling. When you know this theory, you're gonna enjoy using 3D modeling much more than you think. All right. So let's compare degrees to directions. On Scratch, we talk about degrees like 90 degrees or 100 degrees, so many kinds of degrees, right? But also, you might know directions. On your left side, what you can see are north, east, and south, and west. And on the middle, like a northeast, and a southeast, and southwest, and northwest. let's compare the degrees to the directions, right? For example, the left side, north part on the top, right? You can see on the left, there's a directions, and on the top, you can see N. It means north. So pointing north means pointing 0 degree. And let's see east. So the east is 90 degrees, right? And then south, that's the opposite side of north. And what is it? It's 180 degrees. And let's see west. West is 270 degrees, all right? But from 0 point, when you see on the right direction, 0 to 90, 90 to 180, 180 to 270, and then the one round is 360 degrees. But when you see the opposite way, from 0 degree to the left side, left round, 270 means minus 90 degrees. All right. So 270 degrees sometimes means negative 90 degrees or minus 90 degrees. All right. So this is the one thing that you can remember. Cool. Also, we talk about rotation, and you can see this character is turning and rotating. It means the circular motion of an object. It can be measured in degrees. But rotation sometimes means turning or sometimes means spinning. It means the object is rolling, and rotating or spinning or turning. And this is called rotation, right? And also, we talk about the concept called symmetry. The description is here, but I don't know how many have heard symmetry. But let's take a look at this butterfly on your right side. The blue butterfly looks beautiful. Um, see, let's imagine it's so cruel, but let's imagine when you cut this butterfly the half with the center line, you will see on the left side of the butterfly and the right side of the butterfly, it looks exactly the same. Or when you try to fold the butterfly with the center line, like this, where it's gonna be the completely same. The shape will be the same. So this is symmetry. For example, your hands, like a right hands and left hands. Basically, when you put them together in front of you, you're gonna see exactly the same. So this is symmetry. Even your body as well. When you cut your body to half, you're gonna see the right side and left side. It's gonna be completely the same, and that means symmetry. And sometimes symmetry means 180 degrees sometimes. Let's take a look later. All right. So with 3D modeling, for example, when you build robot, maybe you need metal, maybe you need steel, but this time you can use this plastic. It's a prefabricated models, but in Japan we say plastic models. So as you can see, once you create something with 3D modeling, and when you use 3D printer, you can create your plastic model, and you can create anything you want. And we as Robbo have our own mini 3D printer. So once you learn how to build object on 3D modeling, you are able to print them out with a 3D printer. And that's kind of cool, right? Um, let's say this one, rocket. This is actually rocket. And then hope you're gonna enjoy this. That's why I'm just, came outer space and I'm under attack. But I just want to tell you that how to make this cool rocket with 3D modeling. All right. So I hope you're ready, and I am ready. All right. We use the tool called Tinkercad. And let's create a new design with it. First, let me tell you how to use this Tinkercad. What you can see in front of you, it's called work plane. This is basically a plate, and then you're gonna create anything on this plate, all right? And then when you use a mouse, and then when you click, let's say when you hold your right click and then move your mouse, will move like this. Ooh, this is so cool. All right. And when you press shift key on your keyboard and then hold your right click on your mouse and then move your mouse, so the work plane will move. All right. Like this. This is kind of cool. And then when you use your mouse wheel, and you can just zoom in and zoom out like this. And then when you press home button, it will come back the same. Let's take a look. Where is one object? And let's see how it goes. So choose any object you like this. And then once you click the object, you see the small, this white spot. And then when you just click it and then drag it, so you can change the size, height, everything. Even you can make them fly. Oh my god! This plug, this one as well. Boom, 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 boom. And this one too. Let's make it taller, and then let's make it fly. So it's floating. Cool. It's like a zero gravity. Oh my god! And let's take a look. Ooh, this is so cool. Let's take a look this object from the bottom. Whoa, nice. Cool view. And then if you want to take a look at the small spot, you can zoom in and use the shift thing and then make sure that what you want to see is on the screen, and then zoom in again so you can see the small things. Also, you can zoom out and you can see this from the top. You feel like you became a god and you see everything. But now I'm out of space. So let's move forward. All right. So let's delete everything and then press home. All right. So as I told you, as I promised you, let's make a rocket today. All right. So on your right side, this is what you can use. But remember, I just mentioned rotation and symmetry. So let's think about how we can use that theory on the 3D modeling. All right. So first, let's choose round roof. And on this angle, it's so hard to see everything. So let's change the angle a little bit like this and a little bit zoom in. All right. When you click it, see, as you can see, there are three arch arrows. See? So this means, so first of all, how many of you know why we say 3D and what it 3D stands for? So 3D means three-dimensional or three dimension. I mean, there are three sides, right? So this arch, so this three, it means you can rotate the object on the three directions. All right. So let's try on this side. Let's click it. Ooh, this side. This is cool. Or let's try this one. Ooh, this side. All right. And what about this? Ooh, like this side. Did you see it? You can rotate. This is rotation, right? This is rotation. You can rotate in three directions. So that's why you need to know the rotation on the 3D modeling, all right? Okay, so to make a rocket, first of all, we need to rotate this and then make it stand. Um, I just use the arch and then drag it and then move the mouse. But actually, also you can just type in the direction, or sorry, the degrees. So you make sure that the exact number you can rotate it. Okay, cool. And I forgot to do one thing. All right. So first, in this case, 3D modeling, you need to measure so many things. So let me introduce a great tool called ruler. Dun dun. And ruler is the tool to measure the object. And then to use this ruler, you can measure so many types of things, and you're gonna see it. For example, this one, the length is 20, and then the width is no width, sorry, and the 20, and the width is, or height is 10. This unit is millimeter, so 20 means 2 centimeter, all right, and then 10 means 1 centimeter. Okay, cool. All right, so let's do it again. Let's rotate this. Let's say 90 degrees. Oops. But actually, that was the wrong direction. So let's do 100 degrees. So how are we gonna change it? Dun-dun. All right, this is a cool thing, cool direction. As you can see, -5 means actually this object is a middle. See, it's stuck. So let's make sure that every object is on the work plane, right? So 0 means on the airplane, right? Cool. And make sure that the height will be super thin. So let's say 2. Cool. All right. So let's make it let's do like a 36. And then also this one. Let's do, let's say 80. All right, something like that. Cool. Okay, I need one more round roof. Actually, we're gonna use this round roof so many things, so many times today. Um, let's do 90 degrees. And also we're gonna rotate 90 degrees as well. Dun-dun. Okay. And make sure that this will go up on the work plane, and then the height will be 2 millimeters. Cool. And this will be 40, and then this will be 20. All right. Okay, nice. And then we are going to copy this. You can use the keyboard Control C and then copy it, and Control V and then paste. But this is wrong direction because this will be the other side of wing. So let's do 180 degrees, right? All right, the opposite side. See, this reminds you of something, right? What is it? It's called symmetry, right? So now we are making rocket, and then the shape will be symmetry. When you cut on the half, the right side and left side will be exactly the same, right? All right, cool. All right, so again, another round roof, and then 90 degrees. And make sure that this one is on the work plane, and then height will be 2 millimeters. And this will be 3. All right. Cool. And then we're gonna put cool this box on the gap, right? Okay. So this will be 36, and then the height will be 2 millimeters, and then this part will be 10. And let's put it here. Cool. And then the last thing that we need is roof. This is called roof. It looked like a roof on the house, right? And let's make it stand, but this is the different direction, so 180s. And make sure that this is on the work plane again. Cool. And also, so we're like this. Cool. Okay. And then this will be 5. This will be 20. And it was actually too big. All right, something like this. Cool. Okay. Something like this. All right, so everything is perfect. So let's make it a one object. Once you make it, there you select everything, and then you press this button called group. All right, when you group, see, you're gonna see this, and this is just a one object. All right. All right, and then let's make it kind of cool and also personal. You can find a block called text, and then you can put anything you want. For example, my name is Keisuke Kubota, so my initial is K and K. So let's put my initial first, for example, and let's make it a little bit small. And then you remember the turn, let's say 90 degrees. All right, and K, and then put it right on the wings. Kind of fat Keisuke. But okay, it's okay. Let's make it a little bit shorter than the wing. Okay. So it looks cool, right? And let's group it again. So what's gonna happen is that, yay, my initial is on the wing. Yay! So this is my rocket now. All right. So the next one, you can choose either the transparent box, we call it whole box, or you can choose the usual like a box, and you can make it whole by pressing the whole button. All right. And then this board, like 2 millimeters, and also this height is 2, and this one is actually 120. So let's make it 120. Okay, so like this. All right. And don't group it again. Don't group it yet, but you copy it and paste it. And once you see it, nice. You create two things now. And the first one, let's make sure that this will be only half. And then this one will be a half as well. But make sure that this will be from the top, not the bottom, because the other one is doing the same things, right? All right, like this. Cool. And then, as you can see, make sure that this will just penetrate perfectly. So, like this, all right? And cool. So let's group it again. Nice. Oops. All right. And group it again. Cool. So, okay, something like this. Let me see. see like 4 instead. It looks a little bit. Let's make it wider so you can see it clearly. Okay, cool. And let's do it again. To the grouping. Cool. Also, I forgot to mention that you can change this color as you want. Let's say yellow and red. All right. So, Rocket is not sleeping. We have to let him awake. All right. So like this and 90 degrees, cool. And then launch. Make sure this is on. Let's do it. Sorry. Okay. And this one. Oh, cool. And this one, you need to turn 90 degrees, right? Okay, cool. And now we can just assemble it like this. Let's make sure it's right. All right, something like this. Okay, cool. Go down. How does it look? A little bit. Oops, it's not so good. Right. Cool. All right. How does it look? See, my name is on it. And let's see. My name is on it. Nice. All right. Then now we have Rocket. Oh, for example, of course, if you want, you can put this and then you group them and then make it as one object. And then you can change your color like a red or like a blue or a pink or even like a green, everything. But make sure that when you print them out separately, and then once you have the actual like a 2 rockets, and then you can assemble it on the real life. That's so much cooler. All right. Okay, cool. So yeah, we managed create the rocket, and then also I'm still under attack, but I survived. I'm still alive. So great. All right, guys. Hope you enjoyed this session, and I hope you can create your own rocket and take me to the outer space again. All right. Thank you, guys, and I hope you enjoy it. And I really, really hope to see you soon. And again. All right. So have a good one and enjoy the next lesson as well. Bye-bye.
Hi, everyone. Well, thank you so much, Keisuke. That was so interesting. That was my favorite astronaut, by the way. Okay, let's just talk a little bit more about what you need to do because it's just many questions in the chat. So, once again, you go to creativeprogramming.org. There, you find final task. You press it, then you choose your nomination. In your nomination, there will be 3 tasks. Task number 1 is a quiz. You just take a simple quiz with questions about Scratch. Task number 2, you need to solve an algorithmic problem. How? By creating a project on Scratch, of course. Everything is on Scratch here. And the third task is my personal favorite, a creative task that where you will solve some global issue. You need to choose only one topic, only one, and create a project on scratch about this one topic, about how to solve this one single problem. Okay, we don't need you to make all five topics, or make five different projects on scratch about it. Okay, great. Now what can it be? Well, it's a creative task, so that's why it can be anything. It can be a quiz, it can be a game, basically anything you want. Just show us your creativity in solving global problems of the world. Okay, once you're done, you need to press the submit task link that will also be in your nomination, and submit all your tasks. You need to do it before tomorrow, 23:59 UTC. So you have 36 hours to complete these tasks. That's plenty of time for all three tasks. Okay, now that we've got that out of the way, I will also mention the QR code. I hope you didn't forget about it. You can use it and go and sign up for a free trial lesson on programming, on Scratch, on 3D modeling, anything you want, and you will learn it there. Okay, don't forget it's free. If you like the Olympiad, if you enjoy the workshop, if you just overall like participating in such competitions and support Scratch programming language, please donate to the Scratch Olympiad on the official website of the Olympiad. You just need to press the button that says donate. Okay, that was great. I hope you all enjoyed Keisuke's workshop about 3D modeling, and before that, he was talking about programming on Scratch. That was all super super interesting. If you have any questions about the workshop, about the tasks of the Olympiad, you can ask them in the chat for this translation, or you can write a letter to our to our organizing committee, or you can of course use the FAQ link on the website of the Olympiad and ask your question there. All questions will be answered, of course. Okay, I want to talk a little bit about the prizes of this Olympiad. Well, first of all, of course, the best projects are going to the UN with an open letter, and we will send them and show how our participants can change the world, can help all this, bad things happening in the world, and you can make it better. And we are hoping that you will, because you are the future, and your projects, they might help save some of the people in the world that are suffering right now. Okay, basically, the first thing, yes, you're going to the UN if your project is the best. Then, of course, you will get a certificate of the winner of the final stage. That will get, or if you just participated but did not take any, place, you will still get a certificate of the participant of the final stage of the International Scratch Olympiad. Okay, what else? There will be one more bonus that only after the end of the Olympiad we will tell you about it. It's a surprise, and we hope it's a nice one. You will enjoy it. We're pretty sure. Yeah. Okay. So what else should I tell you about this? Olympiad. You can go to creativeprogramming.org and find a link that says rules of the final stage. If you don't understand how to make any project, any task, if it's complicated, if you don't really understand it, you can also read the rules of the final stage. It has a very specific instruction about what you need to do to complete the Olympiad tasks. Okay, so if you have any questions, please read the rules. If you don't find the answer to your question there, please write us a message to our email or to the FAQ section in our website, FAQ of the Olympiad. Ask your question, there will be a link too. Okay, I just want to remind you that if you are not a participant of this Olympiad, if you are a guest, if you're a mentor, if you're a parent, if you just love Scratch overall, you can go to creativeprogramming.org and find a link that says Scratch Quiz. Press it, solve the quiz, and you will get a certificate of a Scratch Master. We will find out how much of a Scratch master you are. Okay. Okay, so if you have any more questions, please ask them in the chat, or you know what to do, where to find the answers to your questions. Okay, great. And now we are moving on to the next workshop of today by Andrew Lutin from our office, from Robbo office in Finland. And he will be talking about circuit engineering today. Please listen carefully. That will be very, very interesting. We hope you learn a lot of new things. Okay, Andrew, here you go.
Hello, and welcome to our circuit engineering stream. So my name is Andre. I'm from Helsinki office in Finland. And today we are going to talk about circuit engineering, or we can also call it circuit design. So electricity, wires, different electronic components like we use in robots, they all belong to this direction. So, and first of all, let us think about different parts we need for a robot. So you might have heard it already today because Kiske also covered this a little bit. So 3D modeling allows us to create a body or chassis. Then programming gives us the opportunity to put a program into a robot to create its thoughts, its behavior. But what's more, for a robot to be able to follow the program, so it needs brains, and that's what circuit design covers. So, and then what circuitry is and what is circuit actually. So circuit engineering is a scientific and technical field, and it is responsible for creation, debugging, or like fixing maybe even electronic circuits and devices. And studying it, we learn how to create electrical circuits, how to manage them, and we get acquainted with some theoretical base as well. So here in the picture, you can see like a circuit. You might have seen it in real life if you, for example, disassembled a computer like I did with mine. Oh, yeah, luckily that's not the one I'm using to stream, so no worries about that. And so circuits always use electricity, and they even cannot exist without electricity. So in modern world, electricity is everywhere. And so circuits are. Actually, earlier we had like maybe even simple toys, but nowadays many of them have like electrical components to make sounds, to talk, to, I don't know, they have different lights and so on. So even simple things nowadays have electricity inside. So we use batteries really often. We use accumulators in different different devices, and electricity travels through many of the things we use, like phones, computers, and whatever. So, but what electricity is? So basically, it is the movement of very, very small particles that travel through the wires at high speed. So these particles give us energy. So it is like a flow that runs through the wires. So if we connect a wire to like a battery, for example, and then we expect electricity to move through the wire to our, for example, light bulb or LED or whatever device that consumes power. So, but the thing is that we need another connection that leads us to the second contact of the battery. So the idea is that circuit has to be closed. So electricity runs in a circle, and that way, and that's the only way it can work. So, and we are going to do a little bit of practice. So be careful when you're practicing with electricity, as it might be dangerous. But luckily for us, we have this online Tinkercad environment that allows us to try it all safely, and we are not going to get hurt. So we can start a new circuit for this, and we'll move on with adding some components here. But first of all, the most common and important thing we are going to use today is an LED. So we drag and drop it to the work plane we have in the middle. And so basically this follows the same rules as Tinkercad you might have seen earlier on our 3D stream. So we can zoom in and zoom out, scrolling the wheel. We can drag components on the work plane. And we have several options here. For example, we can choose a color. So we have green, yellow, orange, blue, red, and white. By the way, let me know in the comments section, what is your favorite color? Well, choosing from this one. And I'm going to pick the most popular color for our LED, okay? So then we need a power source. So LED cannot work, so it cannot get electricity from the air, right? So we need something that is going to give us electricity. So a working element that is going to power some other element, like so that it could light up. So we take this coin battery. Here we can also rotate objects. I think we can put it like this. All right. And what's wrong with our circuit? What do we need else? Definitely wires. So circuit cannot work with no wires. And for this LED, we actually have two legs. The straight one is called cathode, and it's like a minus. It's the negative one. And the curved one is called anode. And this one is the positive connection or plus sign. You can see this plus sign on the battery as well. But what's more important, we have this battery put in a box. So we have positive connector here and negative connector here on the left. So if we connect these wires, positive and negative one, and then we have this start simulation button. So now we were in the building, like building section. But if we start simulation, voila, we have this LED lit up. So that's the most simple circuit we can do. So we just put a power source, a battery, and we put an LED. To make it a little bit more complicated, I suggest adding a switch. So like this, push button, yeah? So if we add this, we can then connect our wires to the button and then from the button to the LED. So I just put this wire to the button connector and I add one more wire to connect this button and this LED. So now if I start simulation, right. It seems that I connected the wires wrong, right? So this one goes directly here and the button actually breaks the circuit here in the middle. So the wires connected to the right side are already in connection and the wires attached to the left side, they are going to be operating or working only after I push the button. So now the LED does not light up immediately. It only starts when I press the button. So that's how we actually use our, I don't know, lights at home. So they are only on when we press the button, right? So anyway, once I push the button, I have to hold it for it to work all the time. And that's not really convenient. I want to just click it and let it be on. And for that, I would need another part. Here it is called slide switch. And if I put this one to the circuit, I can connect it the way it allows me to just click it and switch it on. So now LED is constantly on when this switch is here. And it's when it moved to the right. So now we have two options. We can click like this and the LED is on, or we can switch this slider and then LED is going to be working. All right. So Unfortunately, I see no comments about the LED color, so we'll proceed with the yellow one. So actually, as simple as that circuit looks, we still have more things to practice. But further on, we're gonna need to get familiar with another tool we use. So we'll just end this one for now. And another thing we use is an Arduino. So it is a controller and it has all kinds of connections here. So it's not that big. It's actually as little as that. It can easily be placed on your palm. And this board will help us study the circuitry. This is a board for creating simple and actually not very simple automation and robotics systems. And you can connect various sensors, motors, screens to it and program them. With this board, you can do everything from like flashing lights to 3D holograms and robots controlled from the phone or from a computer. So it gives many opportunities. So what we have here on the board is the microcontroller. So it is the brain of the board. It is actually the most important part, I think. So all the programs and actions are going to be processed there. So it's like the central processor of your computer, but it's smaller and it's not that powerful. But anyway, it is a small computer indeed. So then we have this port for connecting to a computer. So then you can plug it into a computer USB. Then this one is power connection port. So it is a round one. You can see it like this. And then we also have pins for connecting external devices. So I mentioned them like sensors, motors, and whatever. And what's more important, if we look closer at these ports, so the pins are actually divided into two categories. On the bottom, we have pins labeled power, and they're actually responsible for constant power supply. So they are always on once you give power to this Arduino board from USB or from like power supply from if you plug it into the wall. So they always give power. So this one is, they have different voltages like 3.3 volts, 5 volts. So it is they are going to be like plus or positive contacts. Then we also have ground or minus contacts or negative contacts. So for our example with the LED, we could just like put two wires into the plus and ground. And these pins on top of the board, they are controlled and they are not always active. To activate them, you need to give a special command. And that actually, that includes programming. That's the part where programming comes in. So we'll try it out also now. So let us get back to Tinkercad. And we're gonna need a new circuit for this. So let's create it. So here on the right, we have plenty of components. We have different batteries, we have different switches, LEDs, resistors, and for this experiment, we are going to use Arduino board, and it actually does not need any batteries to operate. So when we start simulation, like by default, we have this USB connector plugged in, and we have the power, we have the electricity for our connections, for our circuits. So, and now we are going to use LEDs as well. So let's take this one. Yeah, let us place it down here. So now we can connect a node to this, for example, 5 volts. Yeah. And let us rotate the LED so that it looks better. All right. So, and then we connect cathode, or the negative one, to ground. So if we start simulation now, let us try. Why don't we? Yeah, it's going to be safe here, right? Whoops, it burned. So the idea is that LED got too high current, so it cannot operate directly from the board. We're gonna need a resistor that is going to make it safe. So it is going to protect our LED from too high current, and that way it is going to work fine. All right. So, but that was an easy example, and that's almost the same we did with the battery. But now we are going to do a little bit of programming, right? And as I told already, these pins on the top, they are programmable. And for this experiment, we are going to take another LED, and we are going to connect it to these programmable pins. So, let us, okay, it's right on top of the 7th pin, so why don't we use that? And yeah, we would need a resistor as well for that, because actually the current is the same, so we need to protect our LED. So we connect it to the resistor, and here what we do is we connect it to the ground again. So if we start simulation now, nothing happens, because by default this pin does not have any command, and it does not give power to the LED. So now what we use is actually Scratch programming. Yeah. So we're gonna make it a little bit different. So the thing is, here we are going to program a pin to provide us with the power to light up the LED. So we set this pin, which number it was? 7, I guess, right? So we put this pin into operation, and we are going to use several commands for this. So it is going to give us high power and then low power. But if we start simulation like this, we can actually see no difference, right? Because it all happens immediately. And if you know Scratch already, you know that in control blocks, we have an option to add some pause. So we're gonna use this wait for 1 second block and put one after this command and another one after this one. And as soon as we start simulation now, we have this LED blinking. So that way, that's a very simple automatic system, but it is automatic. It includes programming, and that way we can see that not only we create a current, but a circuit, but we also use programming for it to operate independently on its own automatically. So, and that's really cool, isn't it? So this is a good example of how electricity works and how electricity is connected to programming. So if we want to build a robot, we need to not only put all the electrical components inside its like body, but we have to program so that all the motors, all the sensors, that they work together with the program that is done for them. So, and that's basically all we had to cover. And if you want to learn more about how circuits work and how to program to create automated systems, welcome to classes. Thank you for your attention. Hope to see you again.
Thank you so much, Andrew. That was very interesting, and I hope our viewers agree with us. Again, if you want to learn some more information about circuit engineering or 3D modeling or programming on Scratch, you can go to using the QR code. You can go there and you will have a free trial lesson on any topic you desire. Okay. Guys, this is the final countdown. All the tasks are available on the official website. You can start creating your projects on Scratch now. If you're a guest, you can start solving the quiz about the Scratch. That's just a Scratch quiz link on the official website of the Olympiad. And please, please, please remember to give access to your projects so that we can review them. The deadline for you is tomorrow on Sunday at 23:59 UTC. Please check the correct time for your country. It's UTC, okay? And once you submit the project, we will need time to, review the project. We have our esteemed jury members, Scratch experts that will check your project. Every project will minimum be checked by 3 different experts. So we hope that everything will be fine. Overall, you will get the results on October 1st. You will have about a day or two to appeal it if you don't agree with the results of the Olympiad. And then you just publish the final results of the Olympiad. You will get the certificates, best projects will go to the UN, and there will be one more thing that you'll find out of later. Okay, I hope you enjoyed our broadcast today. I hope you enjoyed the workshops of Keiske and from Andrew. I hope that I was a decent host. And if you like the Scratch Olympiad, please donate on our website. We wish you good luck in participating, in winning this stage of the Olympiad, and we hope that you will be one of the best Scratch experts in your field with time. Okay, thanks again. Don't forget about the deadline. We wish you luck. Bye.